the durable writer history and durable reader state feature. So, durable writer history. It's not a QoS policy in itself, it's more of a feature that's enabled by different QoS policies, and here's how you do it. So, if you want to enable durable writer history, you actually configure it using the data writer's property QoS policy, and specifically you set a plugin name to the history plugin to ODBC. You're basically telling the DDS data writer, don't use RAM to store the history queue. Instead, use an ODBC database, basically a relational database, and you're telling it which database to use. So when you configure this, the writer history, the writer queue, is actually going to be stored not only in RAM, but also on disk in a database. So when you call write, DDS will store data in the local database that's been configured, before returning. So the database is basically a cache of the writer send queue. When you restart the data writer, if the data writer application crashes in the middle of writing, when you restart the data writer will restore its in-memory send queue from the database. So if there are any unacknowledged samples, example, you sent data to a data reader, but it didn't receive it, now you crash. If you restart your application, we actually still have that data that you had sent previously, and now we'll continue to make sure that all the data readers have received it, and they haven't, we actually have a copy of that data to be sent again. So let's take a look at how durable writer history works. Fundamentally, the state of the reliability protocol, including the entire send queue and a list of reliable data readers, and what data needs acknowledgement, is going to be stored by the data writer as it changes, not only in memory, but also in the ODBC database that's been configured. And then that state's restored when the data writer application is restarted, if it ever crashes. So let's take a look. When you send data, data is not only going to be in its local RAM queue, the queue that's in RAM, in memory, but it'll also be stored in the database, not only the data sample, but things like who wants the data and whether or not it's been acknowledged. All that information is stored. So here you send D1, and all that will happen even before the data is put on the network. Once it's stored on a database, then a copy gets put on the network, and it may or may not be received by the data reader. So in this case, it's received, and you send D2, and D2 also makes it into the database, and then D2 makes it onto the network, and it's also received. So this is all good and great. You send D3, D3 makes it into the database. D3 makes it onto the network, but somehow the network loses D3. So the data reader actually doesn't even get D3. You send D4 before the reliability protocol can even detect or repair D3. You've already sent D4, and D4 is also stored in database. And actually D4 makes it to the data reader. And D5 also makes it. But let's take an example here where D1 and D2 have now been acknowledged. So we know that D1 and D2 has been acknowledged. D1 and D2 has been acknowledged. If D1 and D2 has been acknowledged, D1 and D2 will be removed not only from the memory, but also removed from the database, because we don't need to keep a copy of that anymore, because we know the data readers received D1 and D2. But even though we know you got D1 and D2, you haven't said anything about D3 yet. We don't know we need to repair D3, so we don't send D3 yet. You're sending D5. D5 makes it in a database. D5 makes it onto the network. D5 makes it into a data reader. So a data reader actually has received D4 and D5, but D4 and D5 can't be presented to the user application yet because we're missing D3. Now, before we get a chance to repair D3, perhaps the application crashes. Now, if you restart the application, you've got durable writer history configured. You restart your application. The first thing it's going to do is reload its state and the state of the send queue, entire history queue, from the ODBC database. So it'll reload D3, D4, D5. It also knows that there's a data reader out there, and it also knows that that data reader hasn't acknowledged these data samples yet. When this happens, if the subscriber now, if the data reader now sends a NAC, says, hey, I did not receive D3, please resend it, the data writer will now be able to resend D3. Okay, it gets a new packet. This packet makes it. D3 is received. Now D3, D4, and D5 can be presented to user application. The publisher application now sends D6 and also sends D7. Okay, and D6 and D7 are received. Eventually we get an ACK that D3, D4, D5 have been received by the data reader, so we can, again, remove the data from the database. So the only data that's going to be stored in the database are the data that have not yet been acknowledged. Okay, if you haven't acknowledged that you received it, we'll have to keep a copy of it around, and we're not just keeping a copy in RAM, but we'll keep a copy in the disk on the in a database on a disk in case the writing application crashes. So that's how durable writer history works. Now let's talk about the durable reader state feature. The durable reader state feature is not configured through its own QoS, but through the data reader's property QoS policy. Okay, so data reader's property QoS policy will connect the data reader to an ODBC database through many properties. One of the properties is what DSN to use. And there's other properties that you will have to want to configure. Please look at the documentation to see those. Fundamentally, what this does is it tells the data reader to store the sequence number of the last sample that it ACKed for a data writer. So if it's receiving data from multiple data writers, there'll be multiple sequence numbers stored, one per data writer. So it's basically storing the last sequence number that it's ACKed, sent an ACK. And don't forget, this could be an automatic ACK or it could be an application level ACK. If the application crashes and you restart the data reader can be directed to reload, to restore its state from the database. And then it will start ACKing or NACKing from the restored sequence number. Let's see how this works. The durable reader state is stored in the disk. You get a list along with a list of reliable data writers it was connected to and the sequence number of the last data samples that it received for each data writer. Okay, so if the data writer is sending data, for example, it sends D1, and the data reader receives D1 and processes D1, it'll store the sequence number 1 into the database. It's not only process, it has to send an ACK. Okay, so the subscriber has sent an ACK that's received the data, and that sequence number will be stored in the database. Now, if if the publisher sends D2, let's say D2 is also received. Well, D2 is ACKed. By ACKing, it will take that data, that sequence number, and store it in the database. Publisher sends D3. D3 is also on the wire, but again, so for some reason, D3 is lost. Of course, the subscriber doesn't receive it, and therefore it doesn't process it and never sends an ACK for it. You send D5, the application sends D5, and D4. D4, the application, the reader actually receives D4. The subscribing application actually receives D4, but it's not going to ACK that it received D4. It can't. It can't ACK that. Why? Because it still needs D3. Okay. So you send D4, D5. D5 is also sent on the network, and maybe the subscribing application actually gets D5. But again, we're not going to be able to change the last ACK value, last sequence number that was ACKed. The last sequence number that was ACKed is 2 because we're still missing 3. Now, before we're able to get the publisher to send us D3, let's say the receiving application crashes. And the receiving application crashes, well, let's restart. In the meantime, even though the receiving application has crashed, the publishing application is still sending values, let's say D6 and D7. Okay, so D6 and D7 are sent on the network because the publisher doesn't know the reader is gone. So the reader doesn't get any of that data. The reader doesn't have anything because the reader doesn't exist. But let's restart the reader. Okay, the reader is now restarted. Okay, and the first thing it does, if you have durable reader state enabled is it will load the last sequence number from the database. So last sequence number is 2. And when it finds the publisher, okay, finds the data writer, it says, oh, I know you. The last thing I received from you is 2. Could you send me everything from 3 on? And in this case, the publisher says, yes, I have all that information for you because you have never acted. Let me give you D4, 5, 6, 7. Okay, and then D3, 4, 5, 6, 7 is received. And now the subscriber can say, oh, I've got all 7 of them. I'll send an ACK for 7. And then eventually 7 is stored in the database. Okay, so instead of storing the entire queue like durable writer history, the subscriber actually stores far less. It's going to just store the last ACT value or at last ACT sequence number.